Little music. Here's what we know from Tydarius' throw, the fierce and also good-looking. Hey, stop it. Thank you, God. All right, so what we know is x of t being the distance that he threw, being 15.83 feet, y sub t obviously being 0. The time it took of the throw from the throw until it hit the ground was 1.58 seconds, and the initial height was 5.83. The two parts of the y sub t equation that we need to find are theta and the initial velocity. So the first thing we need to find is theta in order to find our initial velocity, but we need to set up our equation for the initial velocity to plug into y sub t so that from there we can find our angle. So we're going to derive what v sub 0 equals from the x sub t equation. So we find that the x sub t is 15.83. We don't have our cosine theta or our initial velocity, and our time is 1.8. So if you take 15.83 divided by 1.58, you get our initial velocity equation to be 10.02 over cosine theta. All right, so from there, we're going to plug in our v sub 0 into our y sub t equation. So here's the initialized y sub t equation. And here is all the values from the throw of the Spear of Justice from Tydarius the Fierce and also good looking. And this is equation here. And so then after this, that's negative 16.1 times 1.58 squared is negative 40.19. And then sine over cosine multiplies equals tangent theta. And we still have that multiplied by 1.58 plus our initial height. Next, y sub t, we plug in 0 for that because that's what it is. We add 5.3 to negative 40.19, and then we multiply 10.02 by 1.58. Then we find tangent theta to equal 34.36 over 15.83, and then theta equals the tangent inverse of 2.17, so then we find the throw to equal 65.26 degrees. Now from here, we plug that into our x sub t equation. We divide 15.83 by 1.58 to equal 10.02. We then have our initial velocity, which we need to find, and then our cosine theta angle there. We find v sub 0 to equal 10.02 over 0.42, and then v sub 0 equals 23.94 feet per second. In miles per hour, that is 16.32.